Check the injective and surjective of the following function. The function is mapping natural number to natural number and the function is equal to x square. So let's see how the graph looks like. We can see it is not continuous, right? And the input and the output values will be not continuous. That is, input values, it's not continuous as in 1.0001 0002. It's not going to be like that. It's going to be 1 2. Just look at this, 3 4 5 6 7 8. It will be in this manner. And in this case, since it's been squared, the output would be, as you can see, 1 and 1, then 2 and 4, so 4, then 9, then 16, then 25. So squares of numbers. Now the question is it injective and surjective? First of all, what is injective and surjective? Injective has to do with 1 1 and surjective has to do with on 2, right? So it is 1 1 because if I give an input of 1 2 3 4 so on and so forth, it will map to a unique value and this value will not repeat again. For an input of 1, I get an output of 1 and this 1 at the output is not going to be repeated with any other value. If I give an input of 2, it is 4. 4 will not come again with any input, right? So on and so forth. But remember, there are values over here. Example 2 and 3. There are values over here. 5, 6, 7, 8. Are they mapped? No. So clearly they are not onto surjective. It is injective but not surjective. Okay guys, so let's do this. So 1 1, that is your injective. Now we have let m comma n belong to n. So what is that we are doing? We are proving with proof by contradiction. So we are taking two inputs such that, so the condition being, I can equate f of m is equal to f of n. That is m square, let me change the color, m square is equal to n square, right? Because f of m, obviously from f of x we get it to be m square. And finally, by taking the root, I can tell m is equal to n, taking root both the sides. And all in all, we can tell that f of x is 1 1, right? So this is your proof by contradiction proof. Next, surjective or onto. How can we prove something is surjective? Well, we have to have, for any possible input, we need to have an output. In this case, it is not so, right? We don't have all the possible output values being pointed out. See, these are all the part of your codomain, but they're not the range. So we'll write it in this way. 3, which belongs to natural number, and the codomain, we need root 3 as its pre-image. Only when, if I have f of root 3, I'll get root 3 square, which is equal to 3 at the output, right? That's what I mean over here. Okay, so this is your pre-image and that's your image. So basically you can write it this way also, root 3 f3. This was possible if it was not natural number, but it is not natural number. But root 3 is not part of your natural number and your domain, and from this I can infer that f of x is not onto. Okay, yes. So please see to that you understand the terminologies, because the entire answer has to do with very simple example, but you have to not miss those terminologies. If not, you're going to lose marks.